So, again, this fancy parabola thing that we do is what's called a quadratic, okay? Called a quadratic because of this little 2 that's here. This squared thing makes it quadratic. And the parabola is the fancy name for our U shape. We talked about our base, or our parent function before, that where we'd go over 1 and up 2, over 1 and up 5, okay? And that chart that looked something like this before when we were doing our vertex form before, where we start to get this U shape. So, we also before, you're like, dang, there's a lot of review to this. But again, I sort of figure with this, then when we get to the quiz, one of these note sheets you'll have somewhere. The vertex, again, is where my graph changes direction. Whether it's going down, and then all of a sudden it starts going up. Okay, thank you. Or if it happened to go up, and then it started to go down all of a sudden. We'll get into some of those too. So, and we also talked about how it can be a max or it can be a min based on if it's at the top of my graph or if it's at the bottom. But here's something we haven't talked about yet that we're going to introduce today. And that's what's called the axis of symmetry. And what it does, it's sort of like if I were to take my parabola and fold it in half, where that middle fold line would be. So for instance, on this one that's drawn here, my axis of symmetry is going to go right here because now I have equal parts on both sides of it. And it's going to be written as line x equals and then whatever my vertex would be. So like for instance here, since my vertex is at 0, 0, this particular one for my axis of symmetry would be x equals 0 because we just used the x value from my vertex to be able to find that. So, and like I said, we're still kind of in review here at the start. So, to get a maximum, because we just saw one that looked like a minimum a minute ago, and I can draw this, you know, anywhere I'd like to. So if I have a parabola here, my a value, my number in front, has to be a positive. Oh no! I'd frown at myself too. I got them reversed. To get a maximum, so yes, pardon me for those of you going with pen, I had one too. My a must be a negative number because I would need my graph to open down. Sort of why I have the frowny face there. You're kind of down. My parabola, hey, kind of opens down. Look at it that way. To have a minimum though, like we had up here, couple of things. Now my a must be a positive number. And my graph opens up. And I can work that out that way. So, once we figure out whether it's opening up or down, based on if it's a positive or negative, we can take a look at one more thing that number in front can do for me. Well, what happens if I put a number in front of x squared, like 2 or 3 or 8 or something like that? If my number is bigger than 1, and let's kind of look at a comparison here. It's always easier to tell what something's going on if you can see a picture of it. So let's say, if it says my a is greater than 1, let's say it's like 5. Now, what I'm going to do is I'm going to put my parent graph first, and then I'm going to put this new one with it. Okay. So, here's my original graph. Okay, here's my y equals x squared. Well, then I did y equals 5x squared. What happened to my graph? It got smaller. It kind of squished. Okay? So my graph is going to shrink, or it's going to get smaller, or it's going to get thinner, or you could put it in a whole bunch of different ways. Whichever way you think makes most sense to you. However, what happens if I stick some sort of a fraction in front of it? Like, let's say I put 1/4 in front of my x squared. It goes way out here. So my graph gets wider or larger. So there's going to get to be a point where we're going to be able to look at an equation and figure out if it opens up or down, figure out if it has a min or a max, figure out if it's going to get skinny or wide. There's going to be all sorts of things that we can look at. So that a value, that number in front that we'll be talking about here as we start to graph more, is called our adjuster because it changes or adjusts how wide my graph is going to be. So you're like, okay, enough of all this review stuff. Can we actually start doing something here? And we can. So, okay, we are going to start doing some graphing here. So, we're going to put a couple of steps here, and then I'll keep this sheet up when we actually get to the back page and graph. We're just going to talk for a second about how we're going to do this, because we're going to use part by hand, part we're going to let the calculator help us a bit. So move this back down. Okay, find the vertex by hand. This is what we started doing yesterday. Because my vertex my first step is to do negative b over 2a to find that h value, to get that first answer. And my second step is to plug in the answer from step 1 into the original equation or expression. So we're going to do negative b over 2a to get an answer, to find the first part. And then we're going to plug that in and figure out, okay, that's the one part of this we really aren't going to be able to avoid more than likely. So that's where most of our work's going to be based, in finding the vertex, sort of like what we were doing yesterday. Everything else, though, what we'll be able to do is we'll be able to get our answers from the calculator or from creating a chart. So we'll play with both, because I don't want you to be stuck with having to use the calculator to be able to do it. And then we can start finding some values, one of which is something new that we're going to talk about today. But we'll get a little info here on the rest of this. My axis of symmetry is x equals, and then what goes in here is the x value of my vertex. So as soon as I know my vertex, I know my axis of symmetry. I wouldn't even have to have graphed it first to be able to look at a picture to be able to figure that out. My maximum or minimum depends. If my graph opens down, it's going to be a maximum. If it opens up, it's going to be a minimum. So there's a whole bunch of information I can get off of this just by knowing a little bit of information about my graph. Now here's a new one though. Here's our last new one with this section. Solutions. They can be called a couple of other things. Sometimes they can be called zeros. Or we may have a little bit simpler of a name for them. We just call them x-intercepts. Where does my graph cross the x-axis? That's basically the question that I'm asking here. Sometimes I'll be able to just look at the graph and it'll tell me right away. Sometimes I may have to calculate it using the calculator or just doing a little bit of math work with it. But what we're going to do is I'm going to show you at the start here how we can do it using the calculator. And then what can we do if I don't have one available to me? You know, what would I have to do at that point? And kind of see how that works. So in a moment here, we're going to flip over to the back of this. We're actually going to finally get to do something with this and see how it works. So we're going to be finding the vertex, the axis of symmetry, its max or min, and our zeros, our solutions, based on what that graph is going to be. And then we'll actually see some of these last things one more time tomorrow in with our vertex form before we get ready to go into quiz mode on this. And I'll flip back to this one in just a second. I see a couple of you jotting a couple of last second things down here, but I'll bring it back up. So I get to the back and I say, okay. So I notice, let me push this up to the top. We'll just kind of go this way. All right, we're going to graph and answer all the questions at the left. Okay, we said before, our first job is always to find the vertex. So I need to know what my A and B values are. And like I said, this is the most tedious step. Not even going to lie. Once I know my A and B, to find the x value of my vertex, I'm going to do negative b over 2a. Okay, so I'm just going to plug those in. Now the negative stays there. And then I plug in my b over 2 times a. And I got to figure out what that is. So let's see here. Opposite of negative 4 is 4. 2 times negative 1 is negative 2. So 4 divided by negative 2 is negative 2. Okay. So I've got the x part of it here. And again, I got to be really careful because if I mix up a sign here in this and I mix up my x, I'm kind of done for the whole problem because my vertex is going to be off. So then to get the y value, I'm just going to go back into this equation, and every place that I see an x, I'm going to plug in a negative 2 in parentheses. Like, now why parentheses? Because when we run into negative values sometimes, and that will happen, I want to make sure I don't have a sign issue. But this is where I'm going to let the calculator help me to not make some of those silly errors that I might possibly make on my own. So I'm going to be careful. So I got negative 2 squared minus 4 times negative 2 plus 1. Okay, let me make sure I type that in right. Yes, yes, looks good. So my y equals positive 5. Now here's how we're going to see if we did this right. Once I get my vertex, and just watch the coolness start. 1, 2, 3. Now, before I put it on the calculator though, just in looking at the equation and my a value, is this going to open up or down? How could I know that right away? It's going to open down because my a value is negative. So I know this is going to open down And when it opens down, I get a maximum value. Okay, and we'll see that in just a second here. Now, for our purposes, I just want you to see both. Because again, the more ways we can see things, the more likely it is it's going to click for us. So I look at my picture, I'm like, yep, it's opening down just like I thought it would before we ever looked. Looks like my vertex isn't about the right place here, but let's find out. If we look at the table, if I get this -2 in the middle, I should see symmetry, and I do. If I get my vertex in the middle, and I look and I see the same numbers are above it that are below it. So if that's the case, I'm just going to go ahead and plot them. So I'm like, okay, so -3, 1, 2, 3, 1, 2, 4, -4, 1, 2, 3, 1, -5, 1, 2, 3. And in just a second, I'm going to show you the cool way we don't even need the calculator to do this. 1, 4, 0, 1, 2, 3. Now, before I connect the dots, I'm going to have you think about one thing here. When we were graphing these, back when we were doing vertex form, once we had the vertex, we just used a formula. And we said, hey, we'd go, well, before we were going up, we'd go over 1 and up 1, over 1 and up 1, 2, 3, over 1 and up 1, 2, 3, 4, 5. I don't have to have a calculator to do this. I can run that same pattern. That's going to happen every time with a parabola like this. And on the next one, we're going to strictly do it that way. We're not going to use the calculator. So I draw this in. And there's a couple of things that I notice. So I'm looking and I say, okay, my axis of symmetry where we go through the center is always going to be at the x value of this. X is -2. So then, you're like, okay, what other information do I need still? Well, what is the max value? The max value is the y value. So at my vertex, that's where my max is at. My max value is at 5. So you're like, oh, so I get two things out of the vertex. I get the axis of symmetry from x. I get the maximum value from y. But what about this solution thing, Harty? Because, again, you said it was our x-intercept, so I kind of see they're going through here. But I don't see, like if I look on the calculator, I don't see anywhere where it says y equals 0. How's this work? Well, here's what we're going to do. On ones that get a little bit more tricky like that, where they're not obvious, here's how I can do this. I'm just going to bring this back up. This is on your last page, so you have it. I just didn't want you to have to flip back and forth. Once I have this typed in like we do, I'm going to hit second. I'm going to hit trace, and this menu is going to come up. It's called calculate. And we want number 2 because we set another name for our intercept. Our solutions are zeros. So here's the part that gets interesting. So I hit enter, and this little cursor flashy guy comes up. And my idea is I'm going to trap the intercepts or the zeros in. So we're going to move our cursor to the left till I start getting near my first answer, which is right here, because I'm looking for where they cross the x-axis. When I'm to the left of it, you're like, how do I know when I'm to the left of it? You can go a couple extra clicks if you need to, but somewhere here to the left of it, I'm going to hit enter with my little blinky guy, and watch what the little question here does. It changes. It says, hey, what's right bound? That means I need to get on the other side because I'm going to trap the answer in the middle. So I'm going to do some arrow in here. Okay, if this is my point, I'm to the right of it now. I can see that. Anywhere over here would work. Once I do that, I'm going to hit enter, not once, but 2 times. And it's going to tell me where my 0 is. And sometimes that can be kind of weird. You can notice the solution is just the x value. So like here to be like negative 4.24. Isn't that a weird answer? But sometimes math, they don't always come up nice. Most of the ones that we do will, but they won't always. Don't let that e negative 12 get to you because we just want the x value. But I see there's one more over here, so I'm going to get it too. So one more time. Second, trace. I want the 0, and again, this is just on the last page of what we did, so you've got it. Now, I want to make sure I'm somewhere to the left of this point where it's crossing x. So anywhere over here is good. I'll hit enter. Then I come along. As long as I'm to the right of this point somewhere, yeah, that's to the right of it, I hit enter not once, but twice. And I get my other funky answer. So this isn't one you're going to be able to basically do guess and check on. These answers are going to get kind of strange. Sometimes, not always, but sometimes, to be able to try these out. So I'm going to do one more here, and then I'm going to do the homework ones, do a couple of those with you too to help out. And we'll have some more time to play with these tomorrow. So I look up at the next one, I'm like, okay. Got to start back from the beginning here. Now let's see, the beginning. Oh yeah, I need the vertex. So my a is 2, the number in front of x squared. The b is 4. Bless you. So I say, okay. So my x is negative b over 2 times a. All right. So there's my x of my vertex, which also, while I'm at it, will be my axis of symmetry. Then to get y, I'm just going to work with this initial equation. While I plug in that x value every time I see an x. And I will let the calculator help me crank this out to make sure I do it right. So let's see here. 2 times negative 1 squared plus 4 times 1. So y is going to be negative 2, which is going to give me my min or max value, but that's the question right now, I guess. Is this parabola going to open up or down? If my a value is 2, which is positive, we're going to be opening up. So since we're going to open up, I'm going to have a minimum, and my minimum value will be that y value I just calculated. Now here's what I'm going to do this time. I'll check it with the calculator later, but I'm going to use what we talked about with our pattern before to prove I don't need a calculator to graph this. So here I remember, okay, my pattern normally, if it's just x squared, is, up 1, right 1, up 1, right 1, up 3. Is it going to be the same if there's a number in front? No, I'm being told, and I agree with that. Because now that up is going to get multiplied by this number. So I want you to see that one more time here so we can get ourselves some more practice with this. So I look, okay, it opens up like we said it was going to. I know where my vertex is now. Whatever that vertex is, I want that x number in the middle. So my vertex started at -1. I see the symmetry. So when I go to plot the other points that I get from the chart, I'm going to take a minute to look at the pattern and see what changed. Now instead of going right 1 and up 1, I went right 1 and up 2. Oh, sort of like this. Instead of going right 1 and up 1, 2, 3, I went right 1 and up 1, 2, 3, 4, 5, 6. Oh, 3 times 2 is 6. So I'm still going to do that up 1, up 3, up 5 pattern. I just times it by whatever that number is that I have in front. And I can get my parabola drawn. Now, here's the cool thing this time. If you're looking for a solution, I'm going to shrink this for just a minute. My x-intercepts are going to be places where y equals 0. If the calculator tells me, where they are, here and here, I'll just use the calculator. My solutions are at x equals -2 and 0, because those are the two places that y is 0. So I may not have to go do the fancy thing with the calculator even to get an answer every time. It's not necessarily the case. So here's what I'm going to have you guys try. Starting today, we're going to work on it tomorrow with this too, so it's not like we're in a monstrous rush here. So this is going to be, okay. Okay. Homework check 11, number 3. What I'm looking for you to do on these, and I'm not even as worried about the solutions as the other stuff. I do want you to find these bottom 4 things though, to kind of see how they work. So I'd look and I'd say, okay, well, let's see. My vertex, okay. My A is -1. Now, normally I find the B value in front of x. There's no x term there. Oh. So my B value is going to be 0, because remember, that's where I normally would find this. So you're like, well, how am I going to do this? So my x is -b over 2a. So -0 over 2 times -1? Well, 0 divided by anything is just 0. That's true. So I know the x value of my vertex is at 0. I also know what my axis of symmetry is going to be. So now to find y, I just plug in that 0. And you're like, well, 0 squared still 0, Harty. It's true. I get my vertex. I get my min or max value, because again, the y value will always tell me that. And if my A is -1, am I going to be opening up or down? Okay, we're going to open down. And when we open down, do I end up with a maximum or a minimum? maximum. So I'm like, okay, so 0, 1. And since it's negative, I'm just going to follow the pattern. Over 1, down 1, over 1, down 1, over 1, down 3, 1, down 3, over 1, down 1, 2, 3, 4, 5, 1 down 1, 2, 3, 4, 5. Now we're going to see just how swift we are, because we're going to double check it on the calculator instead of just doing it originally there. So I see it opens down. Okay, looks kind of like mine does. When I get that 0 in the middle, okay, let's see if my other points worked. So it says I got a point at 1. Oops. Let's try that again. I got a point at 1, 0. Yes. At 2, down 1, 2, 3. Yes. 3, negative 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Awesome. So see, I don't need any stinking calculator. Now, it can help. Ooh, I was going to say, it can help on the zeros, though. Because there's my 2 spots where the solutions are. And I see when I go to the calculator, that's at negative 1 and positive 1. And I'm set with that one. And that's all I'm up to on these. I'm just trying to see. I'm going to peek on the back, make sure. Oh, that's not a nice one. I got to do that one with you too. Let me flip to the back. We'll do the first and the last together, and I'll put you up with the other 3 on your own here. When we play with fractions, I'll help out here. All right. So I got my A and B labeled. It's always my first step. So to get my x, I got negative b over 2 times a. All right, let's see. What is half of 2? 1. So negative 2 over 1 is just negative 2. First part of my vertex is set. My axis of symmetry, which I'm actually going to draw in this time, is set. We're not going to worry ourselves about this. We got this. And now I'm just going to plug that negative 2 in. Say, okay, ooh, calculator, yes please. Fractions and squareds and all this other stuff. All right, 1/2 for our decimal likers out there. I will go to the decimal, 0.5. All right, so 1/2 negative 2 squared plus 2 times negative 2 minus 8. Okay. Negative 10 will be, it will also let me know what my min or max is going to be. Negative 2, negative 10. Holy cow. 1, 2, 1, 2, 3, 6, 7, 8, 9. Whew, almost ran out of room. All right, so there's my vertex. Looks like we're going to be opening up, because I see a positive a value, which means that'll be my minimum. Lucky for me, because if it was a maximum, I'm going to be right off the chart here. Now this might get a little trickier. 1/2. You're like, well, how am I supposed to do that? Do I go right 1 and up 1/2? And then right 1 up like 3/2? Yeah, I don't like this idea. Okay. If we don't like the idea, that's why we have a backup plan. Sure, 1/2 x squared, yes. Graph, yep, looks like it's gonna be way down here, okay. So now, my vertex was at negative 2, negative 10. Notice all the decimals, but they're all symmetrical, so we'll use them. So, okay, here is my center. So at -3, I'm at -9.5. Same thing at -1. For -4, I'm at -8. And also at 0, I'm at -8. And at 1, I'm at -1, 2, 3, 4, 5.5. And at -5, I'm at 1, 2, 3, 4, 5, -5.5. Now, just out of curiosity, I'm going to keep looking at this. Yeah, I'm not going to get any zeros. Okay. I was hoping if I kept going here, I'd get those solutions, but I didn't. So one more time, I'm just going to boost this up just enough. Okay, we've already got our vertex. We've already got the equation in. So now we're just going to do second, trace. We're going to find our 0. We're trapping them. So I'm going to go left here. Keep going left. Sometimes it can take a little while. There's the point I'm looking for. I need this first, my cursor guy to be the left of it, so over here somewhere. So that looks pretty left of here. That works. I hit enter to let the calculator know. Okay, that's my first spot. Now I need that little blinky guy to be to the right, my cursor. So I come down a ways. Yeah, he's to the right there. And I hit enter again, not once, but twice. And whatever the x value is, that's going to be one of my answers, one of my solutions. So if I plugged in -6.47 into x in the equation, I'd get y equals 0. I know, hard to believe with a crazy number like that, but it's true. And then I got to do it one more time, but now I need this guy. So okay, I'm on my way. I'm getting there. He disappeared, but he's coming back. Anywhere to the left, so where I'm at's good. Now, anywhere to the right of my intercept. So there, I'm to the right. 2 enters. One more funky answer. I've got all of my information here, and I'm done. So even if all you feel you're capable of doing right now is finding the vertex, just finding this stuff, that's fine. Just find this stuff. We can do the solution stuff in class tomorrow if we need to. That's okay. But try some of those out. Work that out. If you're still playing a little catch up on the last homework check or two, that's no big deal either. Okay? Those sheets are still over in the folder. You can get those and get those in.